Thank you for coming to Managing Mavericks with fdesetup. And before we get started, there's two things I'd like to mention. The first is that all the slides, speakers, notes, demos, they're going to be available for download, and I'm going to be providing a link at the end of the talk. I tend to be one of those folks who can't keep up with the speaker and take notes at the same time, so for those folks in the same boat, no need to take notes. Everything I'm going to be covering is going to be available for download at the end. So the second is to please hold all questions until afterwards. If you've got questions, make a note of them, and then, talk with me at the end. And with luck, I'll be able to answer most of your questions during the talk itself. At the end. What'd I just say? So to better understand the capabilities of fdesetup and how FileVault management works on Mavericks, let's take a look underneath FileVault 2's hood to see how it handles authentication, unlocking, and decryption. So to begin with, passwords are almost irrelevant to FileVault 2's encryption. Instead, the system relies on a series of cryptographic keys granting access to two other layers of keys. Now these keys are the derived encryption key, the key encryption key, and the volume encryption key. So to give everyone an idea of how the keys are interacting with each other, here's a visual representation of what's happening when you log into the pre-boot login screen. So to take them from the bottom layer up, let's first look at the volume encryption key. Now this is the key that's interacting with the core storage volume that the FileVault 2 encryption process has created. All cryptographic operations on an encrypted core storage volume are unique to that volume because a different volume encryption key is randomly generated for each volume. Now this is the key that's actually unlocking the encrypted volume, and it's also the key that's deleted when a wipe command is sent to a FileVault 2 encrypted Mac. Now on the next level up, there's the key encryption key. Now this key is generated when FileVault 2 encryption is initialized on a particular volume. Now it's used to unlock the volume encryption key one layer down, and it acts as the middleman between the volume encryption key and the derived keys. This middle layer allows the derived keys to change without affecting the derived key's ability to unlock that encrypted volume. Now the key encryption key is the key that gets updated when derived keys are added, deleted, or changed. So with each change, addition, and removal, the key encryption key gets rewrapped to allow for the updated information. And on the top layer, there's the derived encryption keys. Now these keys begin the chain reaction of unlocking the other keys below it, resulting in the unlocking or decryption of the encrypted volume. Now, any derived key can be independently changed without affecting its ability to unlock the two other layers of keys. So, any given core storage volume must support multiple cryptographic users, each with their own derived key. Now, this is important because it means that there can be multiple ways to access the encrypted volume. In the case of FileVault 2's encryption, it means that multiple user accounts can be enabled to unlock an encrypted Mac at the pre-boot login screen. And derived keys are also used for the FileVault 2 recovery keys. That all seems pretty complex, right? So let's walk through this. To break it down further, in this illustration, this process opens the door you're seeing above. You enter your password, and the password is converted to a derived key with the RSA password-based key derivation function. This is otherwise known as PBKDF2. The derived key unlocks the key encryption key, which is represented here by the vault door. Once the key encryption key has been unlocked, it grants access to the volume encryption key. The volume encryption key, represented here by the lock on the house, then unlocks the kernel, and then the OS boots. So how do you get a derived key in the first place? Well, there's a couple of ways. The first is to have your access set up when FileVault 2 encryption is initialized. Now, since there are no pre-existing keys at this point, your access and your password or other means of access get enabled at the same time that the encryption is initialized. Once the encryption is turned on, though, it's much tougher. The bouncer is now standing by the door, and he'll stop you from coming in unless you can properly show that you're legit. Now, the only way to get in at this point is to have a friend who's already on the inside vouch for you. An existing derived key can be used to enable new derived keys. So your friend who's already inside can use his derived key to enable your account. Now, at that point, a new derived key is generated to give you access, and you're good to go. Without an existing derived key available, there's no way to get a new derived key set up. To make a long story short, if you don't have a friend on the inside, you're not getting in. So before we dive into fdesetup on Mavericks, let's take a look at what you can do with FileVault 2 when you're not using fdesetup. Well, you can monitor, unlock, or decrypt a FileVault 2 encrypted boot drive using command line tools, but you can't start the encryption process from the command line using Apple's other native tools. Instead, the encryption needs to be enabled from System Preferences FileVault Preference pane. It is not possible to see who has FileVault 2 enabled accounts without looking at the pre-boot login screen. It can be difficult to enable an account without using the FileVault Preference pane. It is not possible to remove an enabled account without either deleting that account or setting the account password to be blank. And you have to choose between using an alphanumeric personal recovery key or an institutional recovery key using a FileVault master keychain file. fdesetup allows FileVault 2 administration from the command line, and it solves all those problems with its various functions. It will turn on FileVault 2 encryption using a variety of options, disable encryption, allow addition and removal of FileVault 2 enabled users from the command line, supply a current list of authorized users, provide encryption status, and much more. So fdesetup has a number of verbs associated with it. The ones that may be most commonly used in Mavericks are enable, disable, add, list, remove, change recovery, remove recovery, sync, and auth restart. So fdesetup is amazingly flexible when it comes to enabling FileVault 2 encryption from the command line. Start with the simplest method. You would run the command shown on the screen to enable FileVault 2 encryption. Next, you'll be prompted for the username and password of the user that you want to authorize, which is the account that you want to have appear at the FileVault 2 preboot login screen once encryption is turned on. Now, if everything is working properly, you'll next be given an alphanumeric personal recovery key and prompted to restart. Now, one thing that's very important to know is that the personal recovery key is not saved anywhere when you use this method. You'll need to make a record of it when it's displayed, or you will not have it later. You can also enable additional user accounts at the time of encryption, as long as the accounts are either local or mobile network accounts. You run the command as shown on the screen and specify the accounts that you want. Now, as part of this, you're going to be prompted for the account passwords. After that, you'll be given an alphanumeric personal recovery key and prompted to restart. And all the accounts specified should appear at the FileVault 2 preboot login screen. Now, for those who want to automate the process, because, well, that's what we like to do, fdesetup supports importing a property list file via standard input. The plist file needs to follow the format shown up on the screen, and more users can be added as needed by appending new user information under the additional user's plist key. And once the plist has been set up, you would run the command shown on the screen to enable FileVault 2 encryption and reference the information in that plist file. Now, since the accounts and passwords are in the plist file, fdesetup will not need to prompt you for passwords. Instead, the alphanumeric personal recovery key will be displayed, and the user will be prompted to restart. Now, all the accounts specified in the plist file should appear at the FileVault 2 preboot login screen. Now, to avoid the need to enter a password, fdesetup also has a defer flag, which can be used with the enable verb to delay enabling FileVault 2 until after the user logs out. Now, with the defer flag, the user will be prompted for their password at their next logout, and the recovery key information is not generated until the user password is obtained. Because of that, the defer option requires a file location where the recovery information will be written to as a plist file. Now, the plist file will be created as a root-only readable file, and it will contain information similar to what's shown up on the screen. Now, for security reasons, I would recommend that this plist not stay on the encrypted system. It should be copied to a safe location and then securely deleted from your system. Now, if you have a particular user account that you want to enable, you would run the command shown on the screen to defer enabling FileVault 2 and then specify the account that you want. If you don't want to specify the account, you can run the command shown on the screen. Now, if there's no account specified, then the current logged in user will be enabled for FileVault 2. If there is no user specified and nobody's logged in when the command is run, then the next user that logs in will be chosen and enabled. So on logout, the user will be prompted to enter their account password. Once entered, FileVault 2 will be enabled and the recovery information plist file will be created. Now, once that enabling process is complete, the Mac will restart. Now, an important thing to keep in mind about the defer option is that it enables one single user account at the time of turning on FileVault 2 encryption. The defer option does not enable multiple user accounts, and it cannot be used once encryption is turned on. So sometimes this is better shown than explained, so let's take a look at how this works. So we're going to go ahead and log in. And we're going to go into terminal. I have Passme run all my demos. He's really good. So we're going to go ahead and run sudo fdesetup. We're going to be enabling it. We're going to be using the defer option. And so as part of that, we need to specify the file path to that recovery plist file. So we're going to store it as path to recover.plist. Password here is for sudo. And it looks like we're good to go, so let's just exit out of terminal. And now let's go ahead and log out. Okay, so since username was the currently logged in user, that account was chosen. I'm putting in the password for the account. It's going through the enablement process, and once all the bookkeeping and paperwork is done, then it will restart. And here we are at the preboot login screen. Since there's only one account enabled, it's automatically chosen. So let's go ahead and put in our password. One nice thing to know is that as a fail-safe measure, encryption does not actually kick off until you put in your password the first time at that pre-boot login screen. Apple did that to make sure that if something went wrong between the reboot and getting to the pre-boot login screen, you weren't locked out with no way to get in. All right, so we're back in, and let's take a look at system preferences, see how we're doing. So we're going into security privacy, going to the FileVault preference pane, and it looks like we're doing good. Not real world speeds on the encryption, folks. Not real world speed. Okay, looks like we're good. So next, let's go take a look at that recovery plist file. So the first thing I'm going to do is drop into a root shell, because remember, this is readable only by root. And then I'm going to use cat to display the contents. So cat path to recover.plist. And there we go. There's all our information, including that all-important recovery key. Now, another capability of FileVault 2 and Mavericks is the ability to use the alphanumeric personal recovery key, an institutional recovery key using a FileVault master keychain file, or both kinds of recovery key at the same time. Now, seen in the earlier examples, fdesetup will provide the alphanumeric personal recovery key by default. Now, to use the institutional recovery key, the keychain flag will need to be used as shown on the screen. Now, the alphanumeric personal recovery key is displayed, but the encryption will also use the FileVault master keychain file's institutional recovery key. Now, in case recovery is needed, either recovery key will work to unlock or decrypt the encrypted drive. Now, if you want to specify that only the FileVault master keychain be used, both the keychain and no recovery key flags need to be used when enabling encryption. Now, this is something I wish Apple had named a little better, but when it says no recovery key, it means no personal recovery key, so no alphanumeric personal recovery key. It doesn't actually mean no recovery key. If you try to turn on FileVault 2 with no recovery key, FileVault 2 will yell at you, and then it will not work. It will not turn on. I mean, it doesn't break your machine, it just says no. fdesetup is also capable of creating a FileVault master keychain and automatically storing it in library keychains. Now, to do this, an existing FileVault 2 public key needs to be available as a DER encoded certificate file. Now, once that's available, the command shown on the screen will enable FileVault 2, automatically create the institutional recovery key with the supplied certificate file, and store it as library keychains FileVault master.keychain. So let's take a look at how you create a DER encoded certificate file from an existing public key. Now, in this case, we're assuming that there is no pre-existing recovery key. So the first thing we're going to do is create one with the create FileVault master keychain tool. So we're going to go ahead and run sudo security create FileVault master keychain. And we're going to provide it a path, which in this case, I'm just going to have it go to the proper path, which is library keychains, and I'm going to name it FileVault master.keychain. All right, put in our password for sudo. The next password is going to be the one for your keychain. So, this is something that your institution should agree upon as using for your institutional recovery key. All right, it's generated it. It says it may take several minutes. I've never had it take more than a few seconds. So the next place we want to go into is into keychain access. Go into FileVault master. There's our public key. So let's go ahead and export that out. File format should be set as certificate or .cer. I'm going to name it filevault.cer. And I'm going to hit save. And there, out on my desktop, is a DER encoded certificate file ready for import. So pretty easy to do. Now, to specify that only the FileVault master keychain be used as a recovery key, you would add the no recovery key flag to the command. Now, it's also possible to include the public key data into a plist, which allows the use of a plist to set up the institutional recovery key. And the plist needs to follow the format shown up on the screen. So basically, the new value is going to be certificate, and then the certificate information goes into there. So using the public key's DER encoded certificate file, the public key data for the plist can be obtained by using the base64 tool by using the command shown on the screen to export the data to a text file. You would then add the exported data from the text file into the certificate key of the plist. And in that case, what you do is you'd open the text file, select all, copy, paste. And it's only because of the word wrap that the formatting looks weird. If you just put it into the plist, it'll just be one long string heading straight off the page. Now, along with the various options for enabling, it's also possible to force a restart of the Mac once FileVault 2 has been successfully configured. This can help automate the process of enabling FileVault 2 on a Mac if no input from a logged-in user is needed. Now, for example, an organization may want to pre-configure its Macs to automatically encrypt with FileVault 2 at first boot with a local admin account enabled. And it also wants to use only the institutional recovery key. If a plist with the desired account information and the public key data to create that institutional recovery key is available, the command shown on the screen could be run to enable FileVault 2 and force a restart at first boot. Now, since this combines several different enable options, let's take a look at how it works when you run that command to automatically encrypt. Now, in this case, I'm going to be enabling all 3 accounts on this Mac via plist file and setting the institutional key as the sole recovery key. All right, so first thing we're going to do, let's go into terminal. And we're going to go ahead and run sudo fdesetup enable. We're going to specify that we're inputting a plist. We're going to use standard input to import that plist. So it's going to be path to fdesetup.plist. We're going to say that there's going to be no recovery key to queue it that, we're only going to be using only the institutional recovery key. And then we're going to say force restart. One thing that's very important, be sure you're ready for this Mac to reboot, because after you put in the password for sudo, it does it. So it's doing all the bookkeeping, it's doing all the enabling, and then boom.
And your recovery key is in the plist.
Correct. Yeah, the recovery key information is in the plist. So here we go. My 3 accounts are administrator, other user, and username. I'm sure you know them. I'm putting in my password for username. Encryption's kicking off in the background. That's that failsafe I mentioned earlier. All right, and since we forced the restart, I've got this Ghost of Christmas Past terminal session up and running, so let's give it a few minutes to load up. Okay, so actually want to get out of terminal, so let's exit out. And let's go into system preferences and see how we did. So going into security and privacy, going into FileVault, once again, not real-world encryption speed. All right, so encryption is done. Okay, so let's see how we did. FileVault is turned on. Good. A recovery key has been set by your company, school, or institution. That's an interesting message to know about. If you are using the personal recovery key, if it's in the mix, this message will say a recovery key has been set, period. That'll apply if you're using the personal recovery key by itself or if you're using it in combination with the institutional recovery key. The only time you'll see that message if you are using only the institutional recovery key. So we properly set that up. And all 3 eligible accounts on this Mac have been enabled. And the reason I know that is that there's no little button at the bottom of the window saying, hey, you've got more accounts that you can enable. You want to go ahead and enable them? Because that button's gone, I know that all the accounts are done. So looks like we achieved exactly what we wanted to achieve. Now, if you want to use the alphanumeric personal recovery key with force restart, the personal recovery key can be exported into a plist file. Now, taking the example shown up on the screen, the institution's automated setup would run the following command to automatically encrypt with FileVault 2 at first boot using both types of recovery key and a local admin account enabled. And then, of course, after the encryption is done, it would be up to that institution to then grab that plist off the machine. Now, in contrast to all the various options available for enabling FileVault 2 using fdesetup, the command to turn off FileVault 2 encryption is fdesetup disable. There are no additional flags associated with this command. It is an off switch. Now, one other thing to know about is if you have a deferred enablement that goes wrong, it's just not kicking on, you would use fdesetup disable to cancel that deferred enablement. So, good thing to know about. Now, once the Mac has been fully encrypted with FileVault 2, you can add additional users using fdesetup. Now, to do so, you'll need to provide the password of a previously enabled account, as well as the account of the password that you want to add. The command shown on the screen will enable a specified user on this encrypted Mac. The initial password prompt can be the password of any account on the Mac that's already been enabled for use with FileVault 2. Now, for those who want to automate this process, fdesetup also supports importing a property list file via standard input. The plist file needs to follow the format shown up on the screen. Now, when adding additional users using a plist file, the top-level username key is ignored, and the password key value should be either an existing FileVault user's password or the personal recovery key if it's available. Additional users can be added as needed by adding additional user information under the additional user's plist key. Now, once the plist has been set up, you can run the command shown on the screen to add additional users by referencing the information in that plist file. To list all accounts enabled for FileVault 2, fdesetup includes the list verb. Now, to get a list of all FileVault 2 enabled accounts on your Mac, you would run the command shown on the screen. All enabled accounts will be listed with both their account's username and their associated UUID. Now, to remove accounts from the list of FileVault 2 enabled accounts, fdesetup includes the remove verb. You can remove users by using either the account's username or the account's UUID. Now, I'm not certain when you would run into a situation where you would not have the username and you would only have the UUID, but it is nice to know that you have either option. So to remove the account by username, you would run the command as shown on the screen and then provide the account's username. To remove the account using the UUID, you would run the command shown on the screen and then provide the account's UUID where appropriate. fdesetup in Mavericks adds the new ability to change, add, and remove both personal and institutional recovery keys. Now, this gives MacAdmins much greater ability to manage recovery keys, including the capability to quickly update or remove compromised personal or institutional recovery keys in the event of a data breach or other problem. This is huge. And the reason is that if previously you had an institutional recovery key get compromised, you'd have to go get all the Macs that use that institutional recovery key, bring them in, decrypt them, swap out the institutional recovery key, re-encrypt them, send them back out. I don't know about you, that sounds like a pain. It's also very, publicly visible and all that other stuff, blah, blah, blah. So with this, oh, well, that happened. Change. So to change to a new personal key, you would run the command shown on the screen. You'll be prompted for the password of an existing FileVault 2 enabled user or an existing personal recovery key. Once entered, a new personal recovery key will be generated and displayed, and the former personal recovery key will no longer work. Now, for those who want to automate this process, fdesetup supports importing a proper list file via standard input. Now, the plist needs to follow the format shown up on the screen, and you would store either the password of an existing FileVault 2 enabled user or the existing personal recovery key in the password key of the plist. Now, if applicable, you can also import a plist that contains the public and private key for an institutional recovery key. So for the keychain path key, you'll need to provide the file path to the keychain for the plist value, and for the keychain password key, you'll need to provide the password that unlocks that keychain. This is new. One thing to know about using the keychain path and keychain password keys in the plist is that the fdesetup man page notes that keychain path only works with certain commands. Regrettably, it doesn't mention what commands those are. So I did some testing to find out, and it appears as of 10.9.4, you can leverage keychain path and keychain password along with the following two commands: fdesetup change recovery, fdesetup remove recovery. So to change to a new personal recovery key, you would run the command shown on the screen to reference the information in the plist file and change to a new personal recovery key. The former personal recovery key will no longer work. Now, in the event that the Mac in question does not already have a personal recovery key, running the described commands will add a personal recovery key instead of changing an existing one. So for example, you got in a Mac that only has an institutional recovery key, and your standard says, well, I need to have it have both. Well, use this, now you have both. The change recovery function also allows the use of an institutional keychain to authorize the generation of a new personal recovery key. And this institutional keychain would need to have both the public and private keys inside. Now to do this, you would run the command shown on the screen. You'll be prompted for the password to unlock the institutional recovery keychain, and once that password is provided, a new personal recovery keychain key will be generated and displayed. fdesetup can also export that recovery key to a plist file by using the output plist flag. To generate a new personal recovery key and have it exported to a plist, you would run the command shown on the screen. The exported plist should contain information similar to what's shown up on the screen and store the new personal recovery key in the recovery key value. Now to change to a new institutional recovery key, you will need to have the new public key available. if you have a new institutional public key available as a D or encoded certificate file, you can run the command shown on the screen to replace the current institutional key. Now, if an institutional keychain is being used on this Mac, you'll see a message that an existing FileVault master keychain was found and moved. Now, the reason for this is that as part of the process, the current institutional key's FileVault master keychain is replaced with the new FileVault master keychain that includes the new institutional recovery key's public key. Now, while the former institutional key's FileVault master keychain is moved and isn't deleted from the Mac, the former institutional recovery key will no longer work. You can also use the current institutional recovery key to authenticate the change to the new institutional key. Now, if you have a keychain file available containing both the public and private keys for the current institutional key, you can run the command shown on the screen to enable the change to the new institutional key. Now, as part of this process, you'll be prompted for the keychain password of the institutional key that's being replaced. Once entered, the current institutional key will be replaced with the new one. This is getting back to that whole you need the friend on the inside. Sometimes that friend needs to move out. So for those who want to automate the process, fdesetup also supports importing a plist file via standard input. You would store either the password for an existing FileVault 2 enabled user or an existing personal recovery key in the password and have the public key data stored in the certificate key of the plist. So hopefully, by this point in the presentation, this doesn't look new, but I do like to spell it out. Remember, questions at the end. You can also use a plist which references a keychain containing the public and private key of the current institutional key. So for the keychain path, you'll need to provide that file path to the keychain as the plist value. For the keychain password key, you'll need to provide the password that unlocks that keychain. And in the certificate key, you'll need to provide the public key data for that new institutional key. So to change to a new institutional key, you would run the command shown on the screen to reference the information in the plist file and change to a new institutional key. And once changed, the former institutional key will no longer work. Now, once again, in the event that your Mac doesn't have a current institutional key, you can use this process to put an institutional key on the system. So for example, someone has brought in their personal Mac, and for whatever reason, you need to add your institutional key to it. You can run this process and get your institutional key added to their system. So to remove recovery keys, getting into a little bit of a dangerous section here, fdesetup includes the remove recovery verb. You can remove the personal recovery key or the institutional recovery key. And once removed, those recovery keys no longer work. Now, one thing to note is that you can also use this command to remove all your recovery keys. So once the recovery keys have been removed from your Mac, only FileVault 2 enabled accounts will be able to unlock or decrypt it. I'm just going to say, as a public service announcement, I don't recommend that. I don't recommend removing all your recovery keys. They are your backdoor in case your accounts are having problems. However, if you want to, and you're fully cognizant of the risks that you're running, sure. I won't do it. To remove an existing personal recovery key, you would run the command shown on the screen. You'll be prompted for the password of an existing FileVault 2 enabled user or the existing personal recovery key. Now, once entered, the personal recovery key will be removed from the system. Now, for those who want to automate this process, fdesetup also supports importing a plist via standard input. The plist needs to follow the format shown up on the screen with the password of an existing FileVault 2 enabled user or the existing personal recovery key stored in the password key of the plist. Now, if applicable, you can also use a plist which references a keychain containing both the public and private keys for an institutional recovery key. So for keychain path, you want to put in the path to the keychain. For keychain password, you want that password that unlocks that keychain. To remove the current personal recovery key, you would run the command shown on the screen to reference the information in the plist file and remove the current personal recovery key. To remove an existing institutional key, you would run the command shown on the screen. You'll be prompted for the password of an existing FileVault 2 enabled user, and you can also use an existing personal recovery key if applicable. And you can also use the current institutional recovery key to authenticate the removal of itself. So if you have a keychain file containing both the public and private keys for the current institutional key, you can run the command shown on the screen to remove the current institutional key. You'll be prompted for the keychain's password, and then once it's run, the current institutional recovery key will no longer work. For those who want to automate this process, fdesetup also supports using a plist to remove the institutional key. You would store either the password of an existing FileVault 2 enabled user or an existing personal recovery key, if applicable, in the password key of the plist. You can also use a plist which references the keychain containing the public and private key of the institutional recovery key that you want to remove. So, as before, for the keychain path, you'll put in the path to that keychain. You put in the keychain password to unlock that keychain, and that should be it for your plist. fdesetup also has the sync verb, which allows FileVault 2 to check with the Mac's directory service and see which accounts have been changed. Now, its main use currently is to automate the disabling of FileVault 2 enabled accounts by checking with the directory service, like Active Directory or Open Directory, to see which accounts have been removed. Now, if an account has been removed from the directory service, running fdesetup sync on an encrypted Mac will automatically remove the account from the list of FileVault 2 enabled accounts, so it'll disappear from that pre-boot login screen. Now, this sync only affects the account's FileVault 2 status. It doesn't remove the account from the OS, and it doesn't remove the account's home folder. And one thing I do want to say is that there's a reason I kept saying the word remove. fdesetup doesn't know that you went into the AD console, found the account, and clicked the disable button. All it knows is there or not there. If it is there, okay, everything's normal. If it is not there, oh, I should disable that. One other important thing to know is that fdesetup sync does not allow accounts to be automatically added, only removed. Keep in mind, to enable new derived keys, you need to have that friend on the inside. On the other hand, fdesetup is, for encryption. Encryption is designed to keep you out. So it's always good about, kicking people out. That wall is low. To get people in, that's when you have to get past the bouncer. Here we're coming to actually one of my favorite parts of fdesetup, and that's fdesetup auth restart. So fdesetup auth restart allows a one-time restart of a FileVault 2 encrypted Mac, which goes to the regular OS login window instead of to the FileVault 2 preboot login screen. And I've had people say, seems dumb, or seems insecure, or why is that even in there? Here's why it's in there. Imagine you work for an institution that says, if it's a computer, it must be encrypted. Doesn't matter if it's a laptop, doesn't matter if it's a desktop, doesn't matter if it's a headless server. Everything must be encrypted. So, without fdesetup auth restart, imagine you have to, say you've got a headless Mac Mini that's running something important. So, without fdesetup auth restart, here's how it goes. I need to restart my Mac. Okay, restart. Now imagine your data center is inconveniently far away. Say it's 10 miles. Say it's 100 miles. Say it's 1,000 miles. Here's what you need to do next. Where's my phone? Hey, Joe? Yeah, I just had to reboot my Mini again. So, yeah, I need you to grab that keyboard, mouse, and display. Yep, go over to rack 3. Yep, I need you to hook all of it up. And oh yes, it's probably been long enough sitting at the FileVault 2 preboot login screen that it's switched off. Yeah, so you're going to need to power it on. By the way, here's my current password. Thanks, Joe. Now it makes more sense, doesn't it? With fdesetup auth restart, you get to skip that whole conversation, that whole embarrassing conversation. Also, Joe doesn't need your password. Only you should know your password. Now, as this is something that's best shown, here's what happens when fdesetup auth restart is executed on a Mac that's running Mavericks that's encrypted with FileVault 2. So first thing we're going to do is we're going to go into terminal. And just to show you, nothing up my sleeves, we're going to be running sudo fdesetup status so to verify that this is actually encrypted and I am not trying to pull something on you. So bonus, fdesetup status. So FileVault's on. It also looks like I'm using the institutional recovery key on this box. So sudo fdesetup auth restart. I have to put in the password for a currently enabled user or the personal recovery key if that's applicable, and then it just reboots my box. So what's going on in the background is that after I ran that command and provided the password, it put an unlock key into system memory or into the SMC. And then it restarted. Now, the reboot process will automatically clear that unlock key. So it's there just long enough to unlock your disk to allow the kernel to unlock and then the OS to boot. So it's not there very long, but it's there just long enough to get what you need. So at this point, you're back at the regular OS login window. You can log in. Everything's back to normal. Now, some of you may have noticed in Mavericks that when you ran the update process using Apple's installer, it didn't stop at the preboot login screen. You may have also noticed that for certain Apple updates, it doesn't stop at the pre-boot login screen. It is using something very similar to fdesetup auth restart, where it's sticking that key into memory, the reboot process is clearing it out, and then it just takes you back in. Now, I don't know what black magic it then uses to log you back into your account, because that's freaky. But that is the process it is using to at least get you past the pre-boot login screen. Now, for those who want to automate this process, fdesetup also supports using a plist to authenticate the auth restart process. You would store either the password of an existing FileVault 2 enabled user or an existing personal recovery key in the password key to plist. Now, to run auth restart this way, you would run the command shown on the screen to reference the information in the plist file. The auth restart process will authenticate using the information in the plist file, and then it'll restart. Now, according to the fdesetup man page, you can also authenticate using a keychain, and you would run the command shown on the screen to do this. However, as of 10.9.4, this appears to be broken. I also tried it in 10.9.3, it was broken there too. This particular function does not appear to be working properly, and I filed a bug report with Apple about it. So if you also want to file a bug report with this, there's the bug ID that I've been using. Please feel free to duplicate it. And if you want the details of what I filed with them, I filed it right after I filed it a bug report. I went to openradar.appspot.com and basically put in everything that I put into my bug report. So if you want us to go, what did Rich put in? Well, there you go. So there are a number of FileVault 2 management solutions that use fdesetup to manage FileVault 2, and they're available from Jamf Software, Dell, yes, I said Dell, and open source projects. So this grid shows a listing of the management solutions that I've worked with that utilize fdesetup. So if you're looking for one, all have their strengths, so I recommend evaluating them carefully to find the one that meets your needs. Now, this is also not a comprehensive list. There's even more out there. One thing that I've seen encryption vendors increasingly doing is saying, Apple's revving it yearly? I can't keep up with that. You know what I'm going to do? I'm going to make my software utilize fdesetup. So if you, like Sophos Safeguard, I think, went that way. I know McAfee went that way. I haven't heard that PGP is going that way, but it wouldn't surprise me in time. It's going to be one of those things where if they can't keep up, they're just going to use Apple's native tools. So that's another good thing to when you understand fdesetup, since they're all using it, you're going to understand what your vendor's tool can do. fdesetup is a Swiss Army knife for managing FileVault 2. It can enable FileVault 2, it can add and remove users, it can report on FileVault 2 status, it can rotate recovery keys, and much more. If you are managing FileVault 2 encryption in your own environment, I really recommend learning how to use this tool and understanding its capabilities. Properly used, it will save you time, and it will give you encryption options available with no other software. So if you want more information about managing 10.9's FileVault 2 with fdesetup, I recommend checking out the October 2013 issue of MacTech. If you have the MacTech iPad app, and go take a look, it's available for purchasing. And print copies should also be available for ordering from the MacTech website. For more general information on FileVault 2, Apple has released a white paper that describes best practices for deploying FileVault 2 on OS X Lion. Unfortunately, because it is focused on Lion and fdesetup came out in Mountain Lion, it does not cover fdesetup, but it does include a lot of interesting technical detail on how FileVault 2 works that is still current. So this talk has covered just fdesetup. If you notice, I talked about recovery keys. I didn't talk really about necessarily how they work or anything like that. More information about FileVault 2 is available from the other talks that I've given, and the video links for these talks are available here. So the first one, Penn State MacAdmins 2013, that was the Mountain Lion version of this talk. So if you're managing 10.8, I recommend you check out that one. MacSysAdmin 2013 was basically a soup to nuts of FileVault 2 as it applied to Mountain Lion. And Jamf National User Conference 2013, once again, only got up to Mountain Lion, but it covers a lot of specific information on how to manage FileVault 2 with Casper. So if you're a Casper shop, I recommend checking out that one if you're looking to manage FileVault 2 with Casper. So here's some useful links for FileVault 2 and fdesetup, including links to some topics not discussed as part of today's talk. If you notice, a lot of them start with theirflounder.wordpress.com. That's my blog. I also seem to have the most documentation on FileVault 2. And possibly the most important links you will see in this entire talk. Here are the download links for this talk. It's available in PDF format with the speaker's notes, and you can download the Keynote slides with all the speaker's notes and demos. Everything I've been talking about, Keynote slides. Also, feedback link. Feedback link. Good feedback, bad feedback. I can take it, but please, good feedback. And I'm going to leave that up on the screen. And I will open the floor for questions. It looks like we have about 35 minutes left, so have at it. Yeah, yes. Microphone heading your way.
Just out of curiosity, it looked like the serial number in the FileVault recovery file was encoded somehow, or?
Yes, that was, I love VMware. Did you know you can run FileVault 2 in a VMware VM?
Okay, so that's
that's the serial number for a VMware VM. They tend to do something long and weird looking. Though now you can do, can be shorter. They built in some, but yeah, it's not going to look like a standard Apple serial number.
Okay, and the other thing I had, it looked like you were doing the formal export save on the certificate. Is there any difference between that and drag and dropping it out of keychain utility?
Mainly to make sure that you get the format right, because you can export in a variety of formats. So I wanted to show, this is exactly how you do it.
I don't know if there's a real use case scenario where this would actually happen, but I was wondering if you ran the auth restart command and then performed like a NVRAM reset in between that, do you know what would happen? Is that where it's stored, or?
That is an excellent question. It is stored in either system memory, so basically RAM while it's still powered up, unless it supports storing it in the SMC. My assumption, because I have not tested this, my assumption is if you clear out NVRAM and it's sitting in the SMC, that shouldn't affect it. However, if you then did an SMC reset on top of that, that might clear it. I haven't tested that though. So it's possible with a lot of work and effort, you can frustrate its purpose. Yeah, but I haven't tested that.
Just a comment. Auth restart is something I will be eternally grateful for you sharing with us. But you had it in your slides that there's a hardware dependency.
Yes.
Auth restart is not going to work on every Mac. There's a list that you've linked to. Just wanted to.
That is correct. Yes. If you take a look at, you know what? I'm going to do this 1 second, and then I'll make this big. Oh, that's not on the right screen, is it? Okay, so here we go. Boop, 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 boop. There is a command called fdesetup supports auth restart. And what it will do is that if your system supports auth restart, it's going to return true. So that's one way to check whether or not your system supports auth restart. So like for example, where'd my mouse go? So like in the case of my Retina here, if I run sudo, if I can only type fdesetup supports auth restart. Did I spell that right? Yeah, I should have just copied and pasted it, honestly. And in fact, just to make sure I did spell that right. Boom. In this case, my machine does support it, so I'll get a result of true. But yes, on older machines that don't support this, I don't recall, let me just double check something real quick. I think it only returns true. I don't recall if it returns false if it doesn't, but let me take a look. Yeah, it just returns true. Okay. Okay.
In a situation where you have a bound machine and you have someone that's not in the current list, would you put a logout script or something in there to authorize them so they can turn the machine on later?
Is the machine already encrypted?
It would already be encrypted, yeah.
Can't use fdesetup defer once the machine's already encrypted. It works one account, one time at the time of enabling FileVault 2 encryption.
All right, so if it's already encrypted and it's bound, we have to manually go in and add the users then?
You'll have to work with them, yeah. I mean, you'll also need their account password in order to enable them anyway. So I would recommend working with the user. I mean, one way that you could do it, if they have admin rights, is, okay, they don't have admin rights. Yeah, then you'll need to work with them.
The idea is it's a loaner machine, so we want to be able to hand it out and give it to the department, let them pass it out to people to use, but it has to be encrypted.
I guess another question is, why are you encrypting loaner machines?
Because our policy says we encrypt everything.
Policy. Yeah, then it'll need to be a manual doohickey. Or another thing you could do is set up a local user called loaner and just give them that password.
Okay.
So, it's one of those things. I love policy. Policy's fun.
So with network users, what happens like if it's encrypted to their account and then their account is set to like change password next logon? They don't have any network connection at the pre-boot.
So it's set to change at the next login, as in like you went into the...
or like their password expired. Let's
okay,
say.
Or their password expired. What will happen in that case is you'll be able to put in their old password at the pre-boot login screen, and then they'll get stopped at the OS login window. They will not proceed into their account. And as a matter of fact, I have a post on this under Flounder. One second, I will pull it up. It's funny, no, I don't have, oh, that's right. I turned it off because I didn't want to have notifications that are popping up in the middle of my presentation to say, you've got tweets. So give me just 1 second. All right. Actually, let me pull up the page first, then show you. So it's kind of funny. The folks who found this or did the legwork on this were the folks from IKEA, because they had an interesting problem. So this is kind of the scenario you're talking about, where your account password is getting changed outside the Mac, then you boot your encrypted Mac, the pre-boot login screen will then accept your old password. So up until 10.7.4, what would happen would be that it would accept your old password, you'd get passed on to the regular login screen, the OS would not allow the login process to complete, but then you'd get stuck with this situation, this bit of nonsense. Here's hoping YouTube works. Come on, YouTube, you know you want to work.
Everybody turn their Wi-Fi off.
Yes. You want this to work.
No, but I guess, will the user still be prompted for the password change once they get past the pre-boot login screen?
You're jumping ahead. So this is what happened as of 10.7.3. So machine would boot. And then you'd get this. Wasn't that great? There's no logins. So the way it works after 10.7.4 is that it works like this. So unfortunately, Apple has fixed this bug, and it has stayed fixed ever since 10.7.4, because that was a fun one. Load faster. So you put in your password at the pre-boot login screen. At this point, old password, because that's all FileVault 2 knows about. You get stopped at the regular login window. That's when you put in, it talks to AD, and you can put in your new password. At that point, you'll also get prompted, hey, your keychain's out of date. You want to update that?
Yeah, I wish that window was more specific.
Yeah, so do I.
Your old password.
Yeah. Actually, in my shop, I have this in combination with Keychain Minder, and between the two, it catches 90%, and the other 10% is called a help desk. So, but yeah, that's the way the process has worked ever since 10.7.4. Any more questions? A question up front?
When you're bound to a domain and you have that option to do the sync, is that something that you have to run manually, or once you're encrypted, it's...
You have to run that command manually,
Okay.
but you can have your systems management tool run that command.
Okay, I was going to say, make
Yeah.
a latch agent or a latch name and do it, so...
Exactly, yeah. So you can automate that process. It's just that, you know, by itself it doesn't, you need to kick it off. Any more questions? Yes, over there. And then I think we have another one in the back.
So once a machine is encrypted, then a new user logs in, they are not automatically encrypted? Or they're not automatically added?
If they are so there's two ways this gets handled. If it's a network user, no, it does not get automatically enabled. If it is a new local user, after encryption, new local users will get enabled automatically. So if you just go in, create a local user, they will show up at the pre-boot login screen at your next reboot. If it's a mobile network account where it's coming from OD or OpenLDAP or Active Directory, you will need to manually enable that.
So what might be a good deployment strategy for, in say, lifecycle replacement? Would it be good to hand out the machine to the new user unencrypted, have them log in, and then encrypt?
That might be one way to go, because there's nothing yet on the box. You can have them just, because the whole point of encryption is that you're protecting something. And it sounds like when you hand it off to somebody, you're not yet protecting anything. So what I've usually seen work in that kind of scenario is using the deferred option. And then if you need to enable your local admin after the fact, then you would have your systems management tool handle that. But in that case, you would need to enable it using either the password of a already enabled user or using the personal recovery key of the machine. So it used to be on Mountain Lion, and this was actually it's one of those things that was convenient, but it was bad. Admin users, even non-enabled admin users on Mountain Lion, could enable other accounts. So on Mountain Lion, you could actually have your local admin account enable other accounts, even though it wasn't enabled itself, and you could also have it enable itself. In Mavericks, they fixed that, and I say it's fixed because it's actually the way the encryption is supposed to work. Some folks said that's not fixed, that's broken down. I'm like, well, tomato, tomato. But yeah, especially if you're going to be just shipping it off to somebody, deferred enablement, in my opinion, is the way to go.
Thanks.
And I think there was this gentleman had a question in the back.
Yeah, I just had a basic question about using Deploy Studio's abilities to enable FileVault. Have you had any experience? Burn your fingers there?
For that kind of thing, that would be something that I would do as a postponed install in a package. Yeah, you can do it. That's not what Deploy Studio is intended for, but you can do it with an installer package, yes.
And could you speak to Fusion drives?
Specifically what?
Well, Apple sells computers built to order.
Oh,
Fusion
yeah.
drives.
I'm sorry. I'm talking about which specific issue are you speaking of with regards to encrypting Fusion drives?
Well, Fusion drives are a core storage volume.
Yes.
And converting to adding FileVault offers a different core storage.
In this case, what it'll do is it'll encrypt the existing core storage volume that a Fusion drive provides. So, however, I ran into an issue which I documented for somebody else. Let me get that back. Pardon me while I drag the browser back off the window. So. Fusion. You do have to basically encrypting, you don't really have to treat differently. You do have to treat decrypting a little differently, because normally what you would do is run disk-util cs revert, which removes the core storage volume. However, that's a bad idea when you're dealing with a Fusion drive. You want that core storage volume to stay around. So for that, I have a post on this, so if you're interested, you can search for the details. But what you want to use instead of disk-util cs revert is you want to use disk-util cs decrypt volume. And the other thing that'll handle this properly is fdesetup disable. But in terms of encryption, fdesetup should handle it properly. Okay.
So we encrypt all of our computers, and we've actually had to take a solid-state drive out of a box and put it into another box. And FileVault was still functional, still worked. Is
Correct.
there anything that binds the FileVault encryption to the hardware in
Nope.
any way?
Nope.
Okay.
What it is, it's software encryption. It's per volume software encryption. So when you move the drive, the encryption, including the recovery key and everything else, goes with it. So there's nothing that, it's not like there's a TPM chip or something.
Yeah, because like on the Windows boxes, we have the TPM chip and all that stuff. It's
Right.
just, it amazed me, like, well, can we do it? And we've done it successfully. I just didn't know if we were corrupting anything or
Nope.
mismatched IDs or anything. So that's good to know.
You're good. Any more questions? The gentleman in the back, who I harassed all through his last session. This may be revenge, who knows?
No, it's not too bad. My question is on the auth restart. Have you ever tested using auth restart with a firmware update package from Apple?
No. Okay. Yeah, that's one of those things where I just haven't. I am interested to learn of your results.
Yeah, well, I have to wait until the next firmware package comes out, of course, but
it should work okay, because at that I think that even happens before it even tries the boot from the disk. It should be okay, but I really haven't tested that. Gotcha. Yeah, Apple has been doing better since the days of, okay, I need you to install this firmware update, but I need you to stand on your head, reach out like this, so it's gotten better. I mean, it used to be my machines were horrendously behind on firmware updates for that reason. Now it's an OS update, it's like an OS update, it just applies, bongs again, and back up and running. Any more questions? Yes.
I'm wondering if you can speak to the use of the recovery partition, why that's important, if it is important with this whole process.
Could you be more specific?
Sure. So say the guy's question about removing the drive out. Say if you were just to take the HFS volume and try to decrypt that later, would you still need the recovery partition?
No, you don't. Well, for the you need the recovery partition to basically boot the machine, because the way FileVault 2 works, like most encryption available on the Mac, you need a small unencrypted space to provide the tools to unlock the much larger encrypted storage. However, if you're not booting from it, you don't need it. So that's why, for example, you can have a FileVault 2 encrypted external drive, that uses the same encryption. It doesn't need a recovery partition. It assumes that you're not booting from it. So if someone took out the recovery partition, you won't be able to boot it anymore. But if you say took it out, plugged it into a drive dock or something like that, it would, basically the next thing that would happen is you'd get the little password prompt that says, you want to unlock, and it would unlock and mount.
Thanks.
Any experience with cloning tools, carbon copy cloner, SuperDuper, and any trouble there?
As in, you want to clone a drive that's encrypted off to another drive?
Correct.
Do you want the encryption to go with it?
Generally, sure.
No, that doesn't work.
No.
The reason is that the encryption unlocks when you boot the drive, so that tools like Carbon Copy Cloner that work on the like the file level, it's acting just like on an unencrypted drive. So when you send it across, it's taking your files and it's moving them off to another drive, regardless of whether or not that drive is encrypted or unencrypted or whatever. In general, with regards to imaging machines, I would really recommend either taking out the encrypted volume with disk-util cs delete, or just decrypting the box before trying to re-image that machine. However, you can repair a encrypted machine using Disk Warrior. They have support for that, and also, of course, Apple's disk utility.
So when you log into OS X, normally you can select at the login screen username and password. But when you enable encryption, it gives you the full list of all your accounts in the machine.
That's correct.
Any discussion, any words on how or if Apple will ever disable that?
There have been many words on this subject. Apple has not done this. It's hard. And the reason is that it's hard is that unlike when you're at the OS regular login window, you have a bunch of other things that go along with it. That's an operating system. When you're at the FileVault 2 preboot login screen, you're governed by the limitations of EFI. So it's one of those things where it's not that Apple hasn't heard from people. They've heard from lots of people about this. It's a hard problem. Hopefully they solve it one day. But the last time I asked them, which was not at this just past WWDC, because unfortunately I didn't win the lottery, but the previous WWDC when we were discussing Mountain Lion, I asked about this and they said, impossible. Not hard, not we're working on it, impossible. So it's Apple, so they say lots of things are we're not doing until all of a sudden, boom, we're doing it. But as of 2 years ago, impossible. It's not a unique problem. It's just that different tools have basically so for example, like if you're familiar with, what is that? I can't remember it now, but there are several encryption tools that will give you like a log, basically a username in a login window. What they're doing is they're actually giving you a custom preboot where they have specifically built-in support for that themselves, where it's it's kind of in EFI, and they've partially they made it work, but it's not something Apple is doing right now. And if you remember PGP doesn't give you that either. They don't even give you the option to select an account. It's just password blank. So it's a tough problem. Yes?
I have a quick question. This is mostly because this is what we're still using for some parts. We use disk-util cs change volume passphrase to do an initial sort of, it's for text mostly. We recycle the password. How should I see that in relation to what fdesetup does? How is that related?
That's going to be different because what that is doing is that's changing like a disk-based password. And it is possible to encrypt a disk, clone your contents onto it, then enable accounts. And then what you'll see at the preboot login screen is going to be your accounts show up, and then also another icon off to the side that looks like a disk. So change volume is just going to apply to that disk password. And that's not going to be tied to a particular account.
Right. And we use it for text so they can get into a machine if
Yeah.
the user somehow.
Anybody else? Questions? No more questions. All right. Well, we have 11 minutes left. Early dismissal.